Welcome to the Test Guild Performance and Site Reliability Podcast, where we all get together to learn more about performance testing with your host, Joe Colantonio.
Hey, it's Joe, and welcome to another episode of the Test Guild Performance Podcast. Today we'll be talking with Stijn all about automatic result analysis, performance testing, DevOps, and much, much more. Stijn has over 20 years of international experience, including banking, insurance, and telco, as a performance test specialist and test manager using both agile and waterfall models. He has worked in Europe, New Zealand, and Australia as a performance engineer, testing and optimizing complex enterprise solutions. Stijn is also intrigued about the changing world of digital transformation, and he enjoys developing alternative and programmatic testing solutions to enable rapid delivery in line with DevOps principles. So it's really a timely talk. You don't want to miss this episode. Check it out. This episode is brought to you by SmartBear. Listen, load testing is tough. Investing in the right tools to automate tests, identify bottlenecks, and resolve issues quickly could save your organization time and money. SmartBear offers a suite of performance tools like Load Ninja, which is a SaaS UI load testing tool, and Load UI Pro, an API load testing tool to help teams get full visibility into UI and API performance, so you can release and recover faster than ever. Give it a shot. It's free and easy to try. Head on over to smartbear.com/solutions/performance testing to learn more. Hey, Stijn, welcome to the Guild.
Hey, Joe. Thanks for having me on this show. I'm really happy to be here and to be speaking about performance engineering and how we do data analytics.
Awesome. Excited to have you on the show. Before we get into those, anything I missed in your bio that you want the Guild to know more about?
It just explains really well that I'm getting old and doing this for a long time, and that I actually have seen the world changing quite rapidly the last 5 years. And that's also what makes it really, really awesome to be in this field, because everything is changing, so we need to adapt. And that's also what I really like about what we are doing, is doing things better and changing the way we do things.
Absolutely. So what's changed the most in the past 5 years? Because I know it was kind of static in performance testing. I started in 1999, 2000. But it seemed really the past, like you said, 5 years, that things have been accelerating. Like, what's changed?
Yeah, it's all about DevOps. You hear that all the time. DevOps, Agile. It's the waterfall methodology is luckily over. So the way that we now develop features into production is completely different than in the old days, when you had those huge programs of work that took 2 years to deliver. And yeah, the risk that you had putting such a thing live is way bigger than actually putting small features continuously in production. But of course, by doing this, we need to adapt our way of working, being performance testers, because we don't have the luxury of time to be planning for months and then try to execute fully integrated tests in a production-like environment. That just doesn't work anymore. So we had to adapt. We had to change the way that we were doing testing. For me, that has been really exciting, because I think that we bring way more value than that we did in the old days, and that we also are exposed to new ways of working. Like, we do shift left, we do shift right. So left more closely to the development, right to production. So yeah, really excited to do test in production. If I said that 6-7 years ago, I probably would have been fired, because that was just not done. But I think it's really excited to do that, and to do that automated and daily, because it provides you with so deep insights. I call it provides me with a daily picture of the application performance in production, which is really, very valuable. But of course, if you do that, you need to know what you're doing. So shifting left, developers that are now our friends. We are not fighting against each other. That's also fun to know, being able to talk to solution architects to actually look at the design and see how the design will impact performance and how we will actually monitor that in production. Being actually involved through all of those cycles and helping DevOps teams. It's been a a really interesting journey, but I'm also looking forward to the next journey, which is happening, because I mean, you learn with DevOps, but there are also shortcomings that I hope that in the next few months, years, we can address as well.
Nice. I believe in one of your other sessions I saw before I did the interview, you talked about how shift left is important. And that's something you hear all the time when people talk about DevOps. But what seems to be missing or not as emphasized as much is the shift right. So, back in the day, I used to do performance testing, but it was always in staging when you went to production, and it was never the same result. So why do you think shift right is maybe a little bit more important, or an area that people should focus a little bit more on?
That's a good question. I think in one of my blog posts I write about it as well, because if people talk about DevOps, it's always shift left. And then not many people speak about shift right. And I think that's equally important. And why this? It's actually quite simple. When I go to a new client and I ask them, do you monitor your production system? Do you know what the actual application performance is in production? And the client would say, that's a good question, but we are not really mature in it. We don't know, and we wait. We don't have problems. And if we have problems, we will get phone calls, and then we will actually try to solve it. So if I hear that, then I always ask myself, why would we test if we don't even monitor the application performance in production? If we don't take the investment to actually know what the users are doing in production, why would we invest in testing? And that's most of the time an eye-opener indeed for clients that they say, yes, you're right. So looking into an APM solution, or at least some decent log analytics, if you want to go there are options to visualize the performance of real production users. And as a performance tester in the old days, I was still young, that was not my cup of tea. What happened in production, that was not what a performance tester should be doing. That's for operations. And it was really, really hard to get any statistics out of it. But nowadays, I actually also help to create APM dashboards and provide consultancy services to help organizations to look into the performance of their production systems. And then the next step is, of course, you have a production system. And the funny and the good thing about a production system is that's production-like. And it's like what you said, Joe, about a staging environment, and actually the nightmares that we had when we were doing testing and everything was tickety-boo, and then we went live and the performance was slightly different, and it could be worse or way better. And then indeed people ask themselves, your project lead in the old days, why do we do performance testing? If we go live, the performance is completely different. And right, so they're right to ask that. I would do the same. Why do we do so much investment to test the performance of a staging environment while it's different in production? Of course, it does mitigate some of the risks, but it's a good question. So if you have a production-like environment being your production systems, why would we not utilize that system to do decent performance testing in? The question that I do get, because people sometimes don't understand, it doesn't mean that that's the only thing you're going to do. Of course, you're still going to do unit testing, you're doing code profiling, you're still testing your feature on feature level in a test environment. But if you have a production system, at least you should validate your performance, having an APM solution, but maybe also doing load tests in production. And at our current client, as an example, they have a very nice load pattern. So their system is basically being used by 9 o'clock in the morning till 9 o'clock in the evening. And then the load outside of those hours, there is nearly no one on the system. So it provides you with an opportunity, an easy opportunity to actually use that window to do a load test in. And the numbers that you get back, the response times that you measure, they are actually the response times of your production system. So you can actually trust those measurements. And of course, I said before, you need to know what you're doing because you're still load testing in a live production system. But that's knowledge that you need to build up. That task I would not give to a junior performance tester that doesn't know the solution architecture of the client. So you really need to understand that system inside out to know what you're doing. And once you know that and you are 100% sure that the impact and the risk that you take to impact real production, you don't want to cause an outage. Once you understand that, the benefits really, really outweigh the risk that you take to test in production. And Yeah, now I find it very interesting. And if you do that then automated and you have a way to then analyze also the results into an automated way, then it really provides you like a digital image every day of what happens in production. So every single day you see what was the performance today, tomorrow, the day after of the load that you have applied on production. Because if you look at APM solutions, it's a load that is being caused by users, and there is never one day the same. So there are always differences. So it's not always easy to interpret the results. But if you always do the same load test at 7 o'clock in the morning, as example, you get a beautiful image every single day. And that provides you insights in the performance and what happens on that system, which are very unique. And it's a really cool way to look at performance as well.
Absolutely. And I think once again, you had a session on something around this. You have some sort of, I think you called it a robotic analytical framework. Is this what you're talking about getting like a daily snapshot of performance over time in production?
Yeah, that's right. I'm from Belgium, and actually, the abbreviation is we all love abbreviations. When you work in IT, you do need an abbreviation, so we call it RAF, and that's actually a Flemish name. I'm from Belgium, from the Flanders. I do work in the Netherlands now, but anyway. And yeah, so we call RAF our best friend, and the whole thing actually, if I go back when this all started to happen, is when we do performance testing, I always see that the execution and the creation of load test scripts, they can be complex, but in a way, it's something that the performance tester needs to do before it brings value. You only get value out of your test whenever you do execution and do the analytics. So having a very smart way to actually look at results, for me, that's gold, because that's where you bring the value. It's not in the scripting. Scripting is a task that you need to do to get there. The analytics, that's where you actually look at the application performance and where you take decisions on what's going to happen with the feature, what's going to happen with the release. And some people call me Mr. Raw Data. And that's actually, I didn't like it at first, but now I actually do like it, because it's one of the lessons that I learned when I was still working in New Zealand, was looking at raw data is the only way that you can become a good performance engineer. And raw data, for people that don't know it, it's actually when you do a HTTP request, it's measuring the response time of every single HTTP request, so that you don't rely when you do a load test and you have a throughput of, let's say, 600 transactions a minute. You actually do want to see from those 600 transactions a minute, you want to see the response time of every single transaction. And you don't want to only limit yourself to looking at averages. And when you look at the raw data, when you do your analytics, it provides you with, how did I say it? I think I mentioned in one of my talks, it shows you the ugliness of an application. It doesn't, with averages, you make an application look beautifully. Performance looks really better if you look at averages than when you look at the raw data, because the raw data shows the ugliness of the application performance. And when we started on our journey to build that framework, for me, it was indeed key to take that takeaway, that lesson that I learned when I was still working in New Zealand, into our framework. Because I didn't want to look at averages or aggregation to take the most important decision that I make that day. Do I take that feature and do I bring it live? I can't base that on looking at the averages. I need to have deep insights. And that was my main objective at that time, is we need to build something, because I don't think it exists in a commercial tool set, that looks at the raw data when we do an automated test and actually enables me to take a decision, and also in an automated way, based on the analytics that are based on raw data. And having such a framework in place, it actually enables you to completely automate performance testing, because automating performance testing is not about automating the execution of a test, because that's the easy bit. It's not complex to actually automate load runner, JMeter, Neoload, whatever tool, do a test every day at 7 o'clock, or have it integrated with the build tool. That's easy. But doing the analytics, that's a different story. And I believe that lots of people thought it was impossible. And one of my good friends, Stephen Townshend, still works in New Zealand, and he writes a lot of interesting LinkedIn blog posts as well. He has a very popular blog post about the myth of performance testing or automatic performance analytics. And there he actually questions if it's possible to do that, because he at that time still believed that you really need to be a performance engineer, a human, to be able to do that. But I think the times have changed and really can build smart solutions that actually make that possible. And for me, again, that's very interesting. Our profession now is to actually always go one step further. So if you work agile, look at the way that you work and also provide some time to actually improve what you're doing every iteration. And it doesn't have to be big, it can be small. Focus on small improvements in your own frameworks and don't make them over complex, because that's a mistake that we do often. But if you improve it every single time, after a while you do make quite significant progress, and you can actually develop a framework that does do things that didn't exist before.
Cool. You should have called it raw. So
yeah.
to go with the raw data, robotic analytic watcher or something.
Yeah, that's a good. I'm not going to change that anymore. It's too difficult. It's embedded in our DNA.
Yeah, true. So interesting is that I haven't done performance testing in a while. So back in the day, I would use an enterprise solution like Load Runner that had everything built in for monitoring and analytics. And it seems like more of the open source space, they're missing that. But it sounds like even today, you still need something extra to create a framework in order to get the data that you really need?
Yeah, I do believe that. So I don't believe that there is one tool that does it all. And a load test tool, and we call it a load test tool, is actually very, very good in putting load on a system. And that's also the main objective of a load test tool. It's driving load on a system. But if you then look at analytics, and we have been using as an example BI tools like Tableau for a while now to actually look at the data and do business intelligence on data. And you can't really expect from a load test tool with its prime goal to put load on the system to have the same ability as a BI tool to do the analytics. So I call it a 1+1 is 3. By combining like a decent BI tool with a load test tool, uplift your analytics already significantly, just because that BI tool is designed to do data analytics and the load test tool is designed to put load on the system. And I do think that some tools are also looking at integrations with BI tools, which would be make it a little bit easier for people that are not familiar with it to actually use those tools as well.
So is Wrath available? Is it an open source project? Is this just something that you have in-house?
Yeah, it's something that we built in I work for Accenture now, so we've built it in the Netherlands just because I needed to have something that was able to do that. And we're still thinking what we are going to do. We are now using it at several clients in America and the Netherlands. But for us, it's the ability to do something technically better, and that drives me in going to my job in an enthusiastic way. So it's, for the moment, it's not open software. It's not, Accenture doesn't really make products, but when you think smart about things, setting up a framework or combining tools is what people should be looking at.
Very cool. So once again, I started off as a load tester and then I went into automation, but I've never really thought of a performance testing as a test automation framework. So to change my mindset, are there any steps you need in order to create an automation framework for performance or for load testing?
Yeah, there are steps. The first step is that you need to be able to do correctly manually load testing. If you don't know how to do correct load testing in a manual way, then it becomes difficult to automate it. And that seems simple, but it's not simple, because I really believe if you don't look at the raw data that you might be doing it wrongly. But that's my personal view on it. The next step, and that's also when we started building RAV, is define clear requirements and goals. And what you see often, and I've seen it in the past as well, that when you have very technical people building a framework, they sometimes over complexify it and they sometimes lose track a little bit. Oh yeah, let's use this framework or let's integrate it with this component. Well, if you look at the business benefits of what you're doing with that framework, it doesn't add much more, but it makes the framework so complex that you actually need more people to maintain the framework than it's worth using it. So my tip there is really, really keep it simple. Don't reinvent the wheel. Don't let techie guys go mental on technical complexity. And that's not talking wrongly about them. They need to be always look at the goal. What do I want to achieve? And always look back if you're doing that and keep it simple.
So speaking of keeping it simple, so do you recommend people learn Python to help them with their doing things like this?
Yeah, it's a good question because in the old days, I did an attempt to learn Perl.
Oh gosh.
Which was interesting. And there were many languages, but I was very happy that when I was looking at developing the framework that I had an excellent young guy joining my team, and he didn't have any knowledge about performance, but he did know everything about Python. And actually, I wouldn't have cared about the language as long that the language can achieve what we are doing. But Python is if you look at the statistics, it's been used more and more, and it's quite easy to learn it as well. So I think it's a suitable language to write frameworks in, but for sure there are other languages as well. But I wouldn't write it in Java or in an enterprise language because it takes the flexibility away a little bit, and you do want to keep it simple and deployable.
Absolutely. And so, I'm kind of switching gears. Don't know if if they relate to one another, but I keep hearing about lately observability in performance engineering. So what is observability from your point of view? And does these analytics help you achieve what people are trying to find when they talk about observability?
Yeah, good question, because it's one of the talks that I gave. I think it was a few months ago, just before the whole COVID-19 thing started in Greece. For the latest NEOT spec, I talked about observability. And for me, I probably have a different view than other people that speak about telemetry and all difficult things, but I actually talked about a real story. That I was living in New Zealand and I took my kids to the zoo and they were only young. So I have three lovely children. At that time, I had only two, Thomas and Noah. And I took them to the zoo in Wellington. And I was looking around and suddenly I lost my son in the zoo and he was only 2 years old. I was a little bit scared, to be honest. And I needed help from the people working at the zoo. And of course, they asked me, what's his name and how does he look like? And I provided a clear description of my son Thomas, that he was wearing blue shorts and a yellow shirt and didn't talk too much. Okay, so they were looking for him, and 2 minutes later, they did find a 2-year-old boy, but he didn't meet my description because he was wearing white shorts and black shirt, so completely different than I actually thought that he was wearing. But luckily, he did recognize me, and it was quite obvious that he was my son. It could be way more embarrassing. But for me, that's what, in a way, observability is. When we do performance testing, we do get a lot of metrics. But if we don't understand the metrics, we don't look carefully at the metrics, those metrics are just metrics. And for me, observability is a level higher. It's really understanding what you're seeing and getting the right metrics so you can take decisions. And it's all about insights. You do want to get insights into application performance so you can observe what's happening in your system continuously, so that you can trigger or automate decisions when things happen. That would be the ultimate. So if performance goes badly, application performance, not system performance, because there is difference. It depends who you talk to. Because if you go to the cloud and you have a cloud provider, they will speak, as an example, about performance in a complete different way than someone looking at application performance. If you look at application performance, what actually really matters is your end user behavior. If you talk about the performance of a cloud provider, they are mainly focused about still provisioning with enough system resources that the performance of your system is okay. And still now I have to explain to lots of people that system performance and application performance is different. And also when we do talk about observability, you need to know that I rather prefer to have good application performance and the CPU of a server being 100% and the CPU of a server being 10% and my application performance being very badly. It's not a one by one. It's not always linked because ICT solutions are so complex and there are so many bottlenecks. If it was only by system performance that application performance would be bad, our jobs would be easy. But it's not as simple. And I think that observability also in that way needs to be placed, that we need to look at application performance as a primary measurement and system resource utilization. So then I speak about CPU, memory, disk I/O, your heap, your garbage collections as a secondary resource. And bringing that all together so that you can actually get deep insights in what happens at all times so that you actually really, really avoid to get into that war room. That's what we need to be looking at.
Okay, Stijn, before we go, is there one piece of actual advice you can give to someone to help them with their performance testing efforts? And what's the best way to find or contact you?
The most important lesson that I've learned is really looking at your data in a different way and understanding that load tools are awesome to put load on the system and that they can also help with analytics, but really looking at how your application really performs would be my advice. And actually, it doesn't have to be difficult. And maybe some experiment that you might be doing in the next week is when you use LoadRunner or JMeter or Neoload. It's not difficult to export the raw data, and you can do it just manually. And then maybe even open good old Excel and have a scatter diagram of your data and look at the difference that you see. And I don't advise you to actually build a framework with Excel, but at least you can visualize without having an expensive tool that you need specific knowledge with your data and just look at the difference. By looking at that, you might be triggered and might be doing your performance testing in the future differently. If 3 people would do this after this talk, I would be very, very happy. And that's my advice.
Awesome. And Stijn, the best way to find or contact you?
Yeah, I'm not a big Twitter fan. I don't even have a Twitter account, so I'm sorry about that. The best thing, I'm quite active on LinkedIn. So look for my name, you will find it. And if you need any advice, you can reach me via LinkedIn. That would be the easiest.
Thank you, Stijn, for your performance testing awesomeness. For links to everything of value we covered in this episode, head on over to testguild.com/P45. And while you're there, make sure to click on the Try Them Both Today link under the exclusive sponsor section to learn all about SmartBear's 2 automation performance testing solutions, Load Ninja and Load UI Pro. So that's it for this episode of the Test Guild Performance and Site Reliability Podcast. I'm Joe. And my mission is to help you succeed with creating end-to-end full-stack performance testing awesomeness. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Guild Performance and Site Reliability Podcast. Head on over to testguild.com for full show notes,